Good morning, good afternoon, good evening to you all from wherever you're joining this ninth webinar of the WEkEO on the WEkEO DS. Let me show you what we have in store for you today. So today we're giving an expert session on the use of land applications or developing land applications in the WEkEO DS. And for that, we have a few speakers lined up for you. From the WEkEO user support. So we have Stefan Urevic, who will be giving a broad overview of the WEkEO DS. He's been involved in Copernicus user uptake for over 10 years, or GMES user uptake. Then Amin Amrani is a technical expert at our WEkEO user support, so he will be able to answer any of the technical questions that you have on using the WEkEO DS. Geoff is our resident land expert at WEkEO user support. He's been involved in developing land applications and working with the European Environment Agency on developing land products using Earth observation data for quite a few years. And then finally myself, I'm also from the WEkEO user support, and I'm an Earth observation expert by background. So on the agenda today, we have an hour and 15 minutes. We're starting in a little bit with a presentation by Stefan on an introduction to the WEkEO DS and the WEkEO website. I will give you a short overview of the WEkEO data catalog for 5 minutes. And then Amin will show you how to use those data, or what kind of infrastructure you have to your disposal in WEkEO to work with these data, and what the pricing would be connected to that. And then we move over to the main part of this webinar, a high-level introduction and live demonstration of the WEkEO DS by Geoff. We will have time for questions at the end of this session. Just so you know, if you want to ask questions, you can ask them in the chat. So if in the chat window, you'll notice next to typing your message, you have a question mark. Please select that, and it'll show up in our questions and answers. And it's something that we then also at the end, the questions that will be answered live will be shown up here on the screen so that everyone can see them. And if for some reason you didn't have time to ask your question, we didn't have time to answer your question, or something comes up later on, we're always there for you on the WEkEO web portal, through Twitter at WEkEODS, or through our service desk email, support@wekeo.eu. And I will now pass the floor to Stefan to show you what WEkEO is all about. Stefan? We're apparently experiencing some technical issues. Stefan, is your okay? Hello, and unmute. Hello. Yes.
Can you hear me now?
Yes.
Sorry, little technical issues. So good morning, good afternoon, good evening for some of you, as we see that we have participants from really all over the world. That's really nice to see. So I'm going to give you an overview of what the WEkEO DS is. DSs are Copernicus Data and Information Access Services. They were created because of the humongous amount of data that the Copernicus program is making available on a full, free, and open basis. Once upon a time, a British friend made a calculation and found out that the amount of, if you were to put all the Copernicus data on CD-ROMs, on DVDs, on these plastic discs, and pile them up, you would have two piles as high as Big Ben, the tower in the House of Parliament in London. So it's really humongous amounts of data that if you have to download them, if you have to store them on a hard disk, etc., makes it really difficult. So in response to that, the European Commission has decided to launch these data and information access services, and WEkEO is one of them, and we believe it's the most attractive. But in total, you have 5 DSs. Why 5? Because as technology evolves, the European Commission wanted to have competition to really make sure that the best solutions would be offered to the public, to the researchers, to the entrepreneurs, to the startups, and to the service providers that are using such platforms to develop Earth observation-based applications using Copernicus data. So basically, DS was born when originally 4 of the most important entities in the Copernicus ecosystem, EUMETSAT, the European Organization for the Exploitation of Meteorological Satellites, the European Center for Medium-Range Weather Forecast, Mercator Océan International, decided to create this DS, and they were recently joined by the European Environment Agency. This is a stepwise approach in the sense that the system is continuously evolving. New products and functionalities are being added. But the big benefit of having these top-notch institutions behind the DS is that you have basically the producers and custodians of a vast majority of the Copernicus data, both satellite data and service data, that are making this data available to you. So that's a difference with the other DSs, which are run by private companies with obviously a different agenda than the agenda of these public undertakings that are just offering this as a purely public service. So we can, over and above the data from the Sentinel satellites and from the Copernicus services, also offer this IT cloud-based infrastructure for storage, tools to process data, user development and user management, with a lot of tutorials and frequently asked questions that are there for the users. One of the unique features is also the existence of a dedicated high-level user support, because who knows better, for instance, the marine data than Mercator Océan, who is developing the service? Who knows better the land data? Well, the European Environment Agency, which develops a very significant chunk of the products of the Copernicus service, etc., etc. So what does WEkEO contain? WEkEO contains basically all the data from the Copernicus satellites, the Sentinels, and the vast majority of the data from the services. And in today's webinar, we're talking about land monitoring data. So there's basically 4 levels of data for land. One is the global land component, which is developed by the Joint Research Center of the European Commission as an entrusted entity, with all kinds of products relative to land features at coarse resolution, but covering the entire globe. Then you have the pan-European component, which is developed by the European Environment Agency, and that includes a whole bunch of products, among which the most famous is the Corine land cover, which is a detailed, high-resolution land cover data set. Then you have some very high-resolution data sets on things on features such as imperviousness, such as protected areas under the Natura 2000 directive, riparian zones, so the areas around rivers, coastal zones, etc. And you have ancillary data, such as a high-resolution digital elevation model, which is very useful for many different land applications. So as I said earlier, one of the beauties of WEkEO is that the producers and custodians of the data are operating the service, or at least offering the service to the public. Another feature is that the data is not a copy. We didn't replicate the data that is stored in other places to make it available. It's distributed architecture under which all the products are just made directly accessible. So it has several advantages. One of them is you always have access to the most recent data. No, you don't need to wait for updates. There's no latency. The second advantage is we don't need additional storage, additional clouds from a carbon footprint point of view. WEkEO DIAS is certainly the DIAS with the lowest carbon footprint. We have also this very strong focus on user development and user management. This public support material, our expert support, these are among our features. Our support is organized in the following way. You have a level 1 support, which are operators which are able to answer, let's say, simple questions. And if the questions are not simple, they get sent to a level 2 support, which is operated by senior experts. And again, as I said earlier, who knows better the data than the ones who are responsible for either producing it directly or overseeing the production. Last but not least, quite a number now of Copernicus products are being developed on the WEkEO platforms. This is just to say that it's not only reserved for, let's say, scientists or students who want to play with Copernicus data for their research, but it's also being used operationally to deliver services. So we both have large companies that are using WEkEO to produce products for their clients. Sometimes it's the European Commission, sometimes it's just private clients, and many entrepreneurs and startups are using it also to produce applications for the public or for specific professional users. So we're very easy to reach. We can be reached through the WEkEO portal where you have a messaging application. We answer very quickly all the emails that are sent to support@wekeo.eu, but we also operate a Twitter account on which you will find information about our upcoming webinars, about use cases of our material, and we also answer questions as if they were sent by email. So that's it for my presentation. Thank you for your attention, and we'll be there to answer any question you would have.
Thank you, Stefan. So now that you know what the WEkEO DIAS is about, I will show you which kind of data you can find. As Stefan already touched upon, so the WEkEO DIAS gathers all of the Copernicus data and information. And that means that in total, there are 235 datasets available inside the WEkEO DIAS. So that's quite a lot. To get a little bit of an overview of which data those are then, you have data from the Copernicus services, which is the Copernicus Marine Environment Monitoring Service, the Copernicus Atmosphere Monitoring Service, the Copernicus Climate Change Service, and the Copernicus Land Monitoring Service. And then you also have the satellite imagery from the Sentinel constellations. So both, which are, if you look at the particular data portals, they are either managed by EUMETSAT or ESA. EUMETSAT in charge of any marine data or satellites, and ESA in charge of the land, more the land part, distributing Sentinel 1, 2, 3, and 5P. And so today we'll be focusing on the Copernicus Land Monitoring Service and the Sentinel satellite data. We've had some webinars as well on the marine side and the atmosphere side. So if you're interested in those kind of data and which data are available, please have a look at our YouTube portal. So the Copernicus Land Monitoring Service, what is it that you can expect from the products that you find there? There are three different components within the land monitoring service. You have the global component, so covering the entire globe with information and products on vegetation, energy, water, the cryosphere, some hotspots and land cover, and some in situ data, ground-based information. It's a very good reference data set for global monitoring, but also for long time series to monitor what's going on with vegetation on Earth, what's going on with the water cycle. Then you have the pan-European and the local components, and those focus on land cover, land use at a more detailed resolution within Europe. Pan-European means that the data sets cover the entire Europe, while the local components focus more on specific areas, such as, for example, urban areas, riparian zones, coastal zones, and provide very detailed land cover in those areas. You'll also find some additional reference data sets on biophysical parameters, on high resolution layers such as imperviousness, forest, woody elements. So everything that you would need to really understand the environment and the changes in the environment. And then finally, what you can also find is imagery and reference data. Whenever a new product is being created within the Copernicus Land Monitoring Service, so every 3 to 6 years, you can image mosaics are created of high resolution and very high resolution imagery, and those mosaics are made available to you on through the Copernicus Land Monitoring Service. You also have some other reference data sets that can come in very handy in your analysis. A digital elevation model, the hydrographic network of Europe, and lots of data for you to play with. Now, those are often snapshots every few years, but very well researched and implemented to derive land cover, land use. But what if we want to monitor within between those timeframes? That's where the Sentinel satellites come in. So you have both. You have different kinds of satellites. You have the Sentinel-1 satellite series, which is a SAR, a synthetic aperture radar satellite. And that gives you a high resolution information in the radar spectrum across Europe, but also outside of Europe. And those data are available either through ordering them for some of the products, to order them from the archive, or immediately available on the WEkEO DS. Sentinel-2 is a high-resolution optical satellite. So that gives you that you can use that kind of information to derive land cover yourself, to monitor crop growth, to look at deforestation, at changes at a very regular time frame. So with every 5 days in Europe, you will get a new Sentinel-2 image. Sentinel-3 is a lower resolution optical satellite, plus also a land surface temperature or water surface temperature sensor is on board of the Sentinel-3 satellite, and an altimeter. So that provides you with really high quality data sets that you can use to further develop your algorithms. And then finally, Sentinel-5P is an atmospheric composition sensor, which can give you information about trace gases, nitrogen dioxide, methane, and can be used to derive air quality parameters, for example. And very soon we'll also have Sentinel-6 available, which is another altimeter, and those data will also then become available in the WEkEO DS. So how can you work with these data? So you have a viewer within the WEkEO DS website, whereby you can already browse through the different products, find products in a data frame or a period that suits you best, in an area that suits you best, and immediately visualize it already so that you can see if this is really the data that you are looking for, or to have like a really quick idea of what is going on in an area. And to then access the data further, you will shortly hear from Geoff how those data that are then used within the WEkEO DIAS. If you don't want to have just a quick snapshot, but if you want to process the data, there are several cloud-based processing tools available. And you can hear it either now, within 10 minutes, or go to our WEkEO YouTube page and find out more about it. So thank you very much. Just quickly before we move on to the demonstration, I'd like to give the floor to Amin, who will be showing you the infrastructure part of the WEkEO DIAS. Good morning, Amin.
Good morning. Okay, so I will give you a quick overview of the WEkEO IT infrastructure. So it consists mainly of the Jupyter environment and the virtual machines that are made available by WEkEO. So let's start with the Jupyter environment. What is the Jupyter environment? It's an open source web app that allows to create and share documents that contain code and text, augmented text, this kind of thing. So you can create a document from scratch using this interface that you can access by signing in. You have to register, then you sign in. Afterwards, by clicking dashboard on the upper banner, you click Jupyter Hub here. Then you get to this interface. So as I was saying, it's a very useful interface. You can create documents from scratch, or you can also access some documents that are already made available by WEkEO. One of them that is very interesting can be found in the folder public, then WEkEO HDA, and then WEkEO Harmonized Data Access API. And I would advise you to read this document because it contains all what needs to be known in order to use the Jupyter environment. So as you can see here, we have different. Yes.
We cannot see you.
I don't hear you. I forgot to share my screen. I'm sorry. I think you can see now. I'm sorry for this. So I was saying, this is the Jupyter environment interface, and the launcher. That's the first page that you will get, and then by going into public WEkEO HDA, you can get to this document, WEkEO Harmonized Data Access API.IPYNB, that contains the most important information about the Jupyter environment. So as you can see here, we have these cells that can be text or images, as here, or it can be also code. So it's Python code that can be played by clicking the play button here. As if you were in a Python interpreter, it's the same thing. Just in this case, it is integrated in the document, and it can be played one after the other. The variables are stored as if you were on a Python interpreter. So I would advise you to read this document because it's very interesting. It contains all what is related to WEkEO in terms of Jupyter environment. The Jupyter environment is a small virtual machine. It can't actually run all the code that you would like to run because it's it's limited as an environment. So if you have some heavy processing to do, I would advise you to use one of our virtual machines. So this brings us to the virtual machine. How do we get a virtual machine? We go to the dashboard again, and you have this upgrade plan button at the end of the page. Once you click the upgrade plan button, you can choose the plan size. So it's the size of the virtual machine that you want to. You can give us some information about the intended use of the platform. Then you click the submit request button here at the end, and you will we will get a message about this request. So as you can see here, there is a pricing that corresponds to each size of the machine. We have a better table here on the pricing section. So every size of the machine corresponds to a certain price, but we have also these trial periods that are available. And so the trial period is available, and it depends on the size of the machine. So that's what I was saying. So once this virtual machine is made available for you, you can go on this docs section, and if you follow some of the articles that we have for you here, you can actually create an instance of the virtual machine very quickly and start using this virtual machine as if you were on your own computer with this huge capacity that we offer through these virtual machines. So that's all from me for now. I hand it over to Anne-Catherine. Thank you very much.
Thank you very much, Amin. So I hope now you received all of the basic information about how to use or what is available in the WEkEO DS. So let's get started now with the demonstration by Geoff, who will show you how to really practically use the WEkEO DS for land applications.
Great, thank you, Anna-Catherine. Good morning, everyone. Good morning, good day, good afternoon, wherever you are. Thanks for joining this. I'm just going to share my screen. Hold on a second. Okay, and start my presentation. I'm going to start with a short presentation, and then I will, and then give an example of working in the Jupyter notebook. Hold on a moment. That's just starting up here. Sorry, technical issues here as well this morning. Here we go. Swap screens. Right, so we're here to talk today about land applications. So I'm going to do a quick overview and then a demonstration. And so all the things we'll be talking about today are applications that are either driven by Earth observation data in its basic form as imagery, or they're based on Earth or they're related to Earth observation-based products. Excuse me. And so what we'll do is we'll discuss some of these land products and some of the application ideas, and we'll see that there is actually a kind of continuum between the products and the applications, and we should really perhaps be thinking about use cases of these. And so I'll finish off with then some examples and then an assessment of a burnt area for showing how the Jupyter notebooks work. But I'd like to just encourage you, as other people have said, to review the other training sessions that have already been given. They're available on the YouTube channel, and explore the Jupyter notebooks that are available and the data viewer within the WEkEO website itself. And finally, don't forget, you can always ask us questions at support at wekeo.eu. So land products and data, they have a long history from paper maps that were produced up to thousands of years ago through to digital on-the-fly mapping that we have today on our mobile devices. And I've just shown here this interesting map. This is an Anglo-Saxon map from of over 1,000 years ago, but we can still make out, if you see my cursor here now, but in the top left-hand corner there's the UK and Denmark and Scandinavia and Iceland on here, and there's the Mediterranean Sea there with various islands in it. So there's a long history of land products and mapping products, and that produces its own issues, as lots of the things that we use today have a kind of long legacy of production, have been produced by different people in different locations and for different uses. And so that's generated a huge variety of land products. And what we will see within what we do in the land area is that it's far more complicated than when we look at things like the oceans or the atmosphere, where there's actually agreed, rigorously scientifically produced basic physical measurements that they use in many of their products. So what I'm going to do now is break down some of these product ideas into three types: basic, static, and responsive. And so the static maps are what we often refer to as status maps. This is the conventional mapping that we're all familiar with. They're usually produced over a short time period or for a fixed reference point in time, and have rigid or fixed nomenclatures. And these are the conventional cartographic maps that were originally on paper, although we now have digital versions of them produced by mapping agencies and initiatives such as OpenStreetMap. And then we also have the thematic maps, which are a more recent development, which characterize the land surface based on a particular nomenclature. And good examples of those are the Careen Land Cover and Urban Atlas from Copernicus. And we're now moving into an era where we have access to wall-to-wall fine spatial resolution satellite imagery, and we can now start to actually map biophysical properties as well. And these are good examples of the high resolution layers from Copernicus. When I refer to more dynamic products, these are the things that are more process oriented, and they're referring to things that are changing over time very dynamically. They're related to some process or activity in the environment. Good examples of this are crop growth or phenology of vegetation, or the changing water levels in wetlands, for instance. And these biophysical properties are often related to some property of a vegetation, such as biomass or leaf area index, and how they change over time. And from Earth observation, we can address these through spectral indicators in the first instance, ways of converting the image data into a useful or actionable piece of information on how the sort of characteristics of the surface, and then how it changes over time. So on the right, we can see a true color satellite image. We can then see a normalized difference vegetation index. And then at the bottom, we can see how that index changes over time, and therefore gives us this dynamic information. And the final class is what we refer as responsive products, and these occur or are produced in response to an event, which is normally some kind of emergency, such as flooding, fire, eruptions, etc. And these layers are then particularly related to a particular instance in time. In this case, the example is a Copernicus Emergency Management Service flood extent map. So we can see the extent of the flooding against a base image and some reference information. So we have this whole range of products, but land applications rarely kind of relate to a single product or a single input data or a single image data set. And we often have to use more than one product or data in order to make our application work successfully. And this is particularly so when we deal with dynamic systems or processes, because things are rapidly changing over time and we need to see them in the context of other information. And I've just added this little cartoon here, which is often used in GIS demonstrations, just to show all the multiple layers that could go together to produce an analysis for a particular location. But if we look at some examples, things like continental scale land cover mapping, for instance, like the Korean map, it's driven by satellite imagery, but then this imagery is interpreted in the context of a range of other information, such as cartographic maps, even down to the street view type imagery, which is now available online, can be used in order to help interpret that mapping. Habitat mapping is another example where we want to know something about the floristic characteristics of a surface, understand the management practices that are applied to an area to understand whether the condition of a habitat is improving or not, as the case may be. And finally, if we look at crop yields, yes, we need some satellite imagery on the changing crop growth, etc. in a field, but we'll also need to combine that with things like weather information, farm management practices, soil types, etc. So land applications can end up being quite complicated activities. And I just want to run through three sort of rather simple examples here of just how we can look at a different data set. So we have an image background here. This could be a VHR, very high spatial resolution satellite imagery, or aerial photography. And I've overlaid it with some thematic data. So this is the riparian zone product from Copernicus. And we can see that the map is focused on rivers, obviously, and we can see it's giving us information about the area around the river. But if we combine it with this image base map, we can then look within each of those classes, within each of those objects, and find out some more information. For instance, in the top left there, along the river where the wetlands are, we can see there's also some areas of standing water which make up that wetland habitat. So we can then start to combine these data sets to get additional information and building an application on that. Another good example is combining a biophysical layer, in this case the high resolution layer for tree cover density, with some reporting units, and the red lines here are forest compartment maps. So you can see for this commercial forest area here that the different compartments have very different characteristics. Some are completely covered in trees, some are only partially covered, some have quite interesting combinations. The top center there we have a parcel which is has some very mature trees, has an area with no trees, and then it has an area which is regrowing. So this is telling us something about the growth stage of those forest areas. And in the bottom left here, we can see some areas of the very mottled effect, which may be related to thinning, where trees are taken out to encourage other trees to grow stronger and taller, etc. And my final example is something we're going to be looking at in the Jupyter Notebook in a few moments. So this is an example where a whole range of information has been combined together to produce an application or use case. And so here we have a situation map from the Copernicus Copernicus Emergency Management Service, which combines a base image with various vector data sets of roads and buildings. And then over the top of that, we have a fire extent, which could have been derived from the imagery or automatically or from a visual interpretation. And we also have some hot spots of where fires are known to be burning. So there's a whole range of information has been combined here to provide this very powerful and very useful land application. So just to kind of sum up there, you've seen that I've shown lots of different data and information being added to those applications, and the DASs and WEkEO in particular give us a really powerful tool for undertaking that type of land application development. So we have the data sets that we mentioned and have been described to us, and those are easily accessible through the data portal side. So here we're looking at both Korean and some Sentinel data here for a particular location. And we also have those cloud processing tools that Amin was talking about. And so we're now going to go on and look at a Jupyter Notebook, just an environment where we can quickly access data, do some analysis, do some visualization, and generate a prototype application very easily. So to summarize my presentation part here, it's it's vital that we use geospatial data in terms of images, products, etc., and maps when we're developing these land applications. And we've moved a long way from the historic point sampling type approaches, and now we have this detailed wall-to-wall satellite-based information that we can use to drive applications. And to deal with these capabilities and capacities that are being generated by Earth observation systems, we do need things, we do need infrastructure in order to kind of make that happen successfully. And luckily, we now have these cloud processing environments which allow us to hold information and process it without having to go through the costs and energies of downloading and then working on it locally. And so I think it's a good opportunity. The DAOS, the WEkEO DAOS is a good opportunity for people to develop land applications, and it will be interesting to see what comes out in the longer term as the this approach to developing land application becomes more mainstream. So thank you for that. I'm now going to change screens and move over to a Jupyter Notebook. So let me just get that ready. Okay, can everyone see that now? I've moved over onto another screen. Okay, I'll assume yes. So what we have, this is the interface that Amin showed us, and what I've done is I've just written a short Jupyter Notebook here, which goes through some processing steps, which show an example application. And then these are the sort of things that you would do if you were generating your own application in the Jupyter Notebook. So I've embedded in here some text, sort of explanatory text, and some nice images and examples, etc. So I won't read through them in detail, but what I will do is I'll just step through the processing parts of the code and tell you what's happening. The one bit I've not included here, this is point 1, which is actually accessing the data itself on WEkEO, but that's been covered by lots of other presentations, and you can find examples on the WEkEO YouTube channel in order to find out how to perform those tasks. And there is in the land part of the demonstration Jupyter Notebook, there is actually an example of how we download that data. So the first thing we have to do in lots of these Jupyter Notebooks is actually to set up some libraries. So we have this section of code here which just imports libraries and sets those up for the use further down in the code. I've included also in here just some explanations of the data sets we're using. So we'll be using some Copernicus 2 data. And it just shows here the details of the Copernicus bands relative to the Landsat systems, as they're very similar classes of Earth observation satellite. The first thing we need to do then is open the files that we already have downloaded from the previous Jupyter Notebook. And what we want to do first is show some visual examples of the imagery, and so we're picking up a few different spectral bands from the imagery, and also the Sentinel 2 comes along with a ready prepared true color image that can be downloaded, so we're going to make use of that as well. So the first step then is to sort of display these true color, and we'll also display a false color image as well to show what other information is available in the image data. So the first step is in here then is to set up a display that we're going to, in order to show these plots. And what we have to do with the imagery, we have to do a little bit of scaling and building of the false color image, which is in this section of code here. It looks rather complex, but all we're doing is normalizing the image and then making some adjustments because of the actual image itself. So on the left here, we see the Sentinel 2 scene that we've downloaded. It's of northern Corsica, and luckily we can now check that it is the right location. This is northern Corsica, the Tyrrhenian Sea, and Elba. And we have some clouds in the imagery and lots of open water. In the a false color image. We built that from individual bands rather than using the ready-made true color image. And so we've used green, red, and near infrared here. And so vegetation appears red due to its strong near infrared reflectance. And we had to do some adjustments here in the code just to display that. So and that's what's generated this warning message here. It's just an overflow message there. But I just had to scale this because this image contained both very bright high white clouds, but very dark water as well. This image came out quite dark, so we've just scaled it to make it appear more reasonable. And what we can see here, this is obviously the same image, just with different bands. So what doesn't really stand out on here is the fact that we have a burn scar in this area, but we can see it on the false color infrared image, and we can see this dark patch here is the burn scar. So what we're going to do now, we know we have the right image downloaded. We're going to zoom in, but also look at some spectral indices. So this is one way we can convert the image data into useful information, and then we can use that as part of our application. So we're going to look at two indices. There's the normalized difference vegetation indices, which is very common, and which scales between -1 and 1, with a greater value for where there is healthy, dense, active vegetation, actively growing vegetation. And then we have the normalized difference water index, which gives us an indicator of where there is open water in the imagery. So before we get on to do that in detail, what we're going to do is load some vector data. This vector data is just an area of interest. So that's going to allow us to zoom into our area of where the burn scar is. And as you'll probably be aware if you've used multiple geospatial data sets before, that we often run into issues of having different coordinate reference systems. So once we've loaded that file, we then just check that it has the same coordinate reference system as our Sentinel-2 image, and then it doesn't. So we do a quick conversion here to make sure it has the same EPSG code or same coordinate reference system. So we then have two blocks of code which are virtually identical, but they're just applying the normalized difference vegetation index or the normalized difference water index to that image. So we can say we're picking up certain bands here, applying some very simple band maths, and then writing the result out to a TIFF file, to an image format. So you can see how you could take this block of code and then alter it for different spectral indexes. So that we don't have to display the whole image all the time, we're then going to crop those images. We'll crop the true color image, the normalized difference, and the normalized difference vegetation index and the normalized difference water index to the AOI that we've already loaded. So we have a section here where for each of those images, the file is opened, and then a mask is applied based on that area of interest, and a new mask data set is written out. So we have 3 blocks of code there doing that process, and then we go on to displaying them. And so I've included some text here which explains what we're seeing there. There was a fire in this region in July 2017, and the imagery we're using is from the 2nd of August 2017. So just immediately after the fire, just a few days after the fire. And then we're displaying that with appropriate scaling of the axes, and we're adjusting the color tables as well. So again, we have these sort of multiple blocks of code here, which are taking each of those 3 images, true color, NDVI, and NDWI, and then scaling them and giving them an appropriate color bar where necessary. So here's the result here. So you can see we've zoomed in on the fire. This is this dark brown area here, and then we can see how it appears in the normalized, in the NDVI and in the NDWI, and we've added these color ramps here for to show those up. Now there may be some issues with people who can see various colors, or so if the colors don't appear useful to you, there's a way of changing the color bars, and there's a link here to how those color bars color ramps can be adapted, and then they're just entered in the code here where we see CMap, etc. So you can change that to something that suits you. I've chosen a green for the vegetation one, and then a ramp that goes to blue for the water index. But we can see here that the extent of the burnt area, and then the vegetation index that's got really low values now. So that's shows that the vegetation has been burnt off there, and there is no photosynthetically active vegetation in that area. We've seen a similar picture in the normalized difference water index as well, but we're also seeing here that we're highlighting the water in the lagoon and the open sea in the top right corner there. So that shows that we can then pull out some additional information about what is happening in this burn scar for inclusion in our application. So we could say something about how the NDVI had changed in this area relative to the unburnt areas nearby, etc. And just to show that how those NDVIs and NDWIs stack up, we can actually do a histogram of those areas, and we can then see what the higher number of pixel values represent different parts of the imagery. So we have peak here in the NDVI image related to the vegetated areas, and then another peak related to the bare areas, which includes the burnt areas as well. So yeah, conscious of time, I'm just going to move on now. So that's how we could use the imagery and spectral indices as an input to our application. Another thing we can do is to take a thematic map and see how the burn scar appears in that thematic map. So we're going to use the Careen data, which has been mentioned quite a lot already today. So which is a thematic map with 44 classes. It's produced wall to wall by the member states of the EEA in Europe, and it's been around since the 1990s. So we have a long time series, and it's produced every 6 years. So it's a very useful product for developing applications that look at changes over time. So the first thing we have to do is pick up our data set. We're setting up some paths here so that we can go and find that data set. And also we have a legend, as this is a thematic data set rather than a continuous variable like the spectral indices. We actually have a legend or a description of what all the classes mean, what all the values in the image mean, data set means, sorry. So what we're going to do is, again, we're going to subset the Careen data for the area of the burn scar. And so again, we have to do another translation of the coordinate reference system. So the area of interest is converted again to get into the Careen correct coordinate reference system for the Careen data. And then we again with similar block of code to above, where we apply this masking in order to chop out the area we're interested in. Now there's quite a large block of code coming up, which is related to how we deal with the legend. And so the legend is held in a text file with codes and class names. And so this block of code here just processes that. And I won't go into detail here, but what it shows here underneath what the Careen data looks like at level 3. So it's a hierarchical classification. And so all the classes that begin with a 1 are related to urban features. All those with a 2 are related to agriculture. 3 is related to forestry and semi-natural areas. 4 is wetlands. And then 5 is water. So these are all the classes that we have available within Careen. So once we have that legend, we're just going to reduce it down just to the legend that we have in our area of interest. So this is another block of code that does that here. And then finally, we get to the point where we can display our Careen data for the area of interest. So this is the same area that we saw in the Sentinel-2 data above. And we can see here that we have a range of land cover types present there. You can see that the burnt area comes out as this large black patch. It's a good color assignment there for that class to show where the burnt features are. And we can see that the mountainous areas here to the west are dominated by various woodland types and natural vegetation. Sclerophyllous vegetation is particular to the Mediterranean area. Then we have a coastal strip which is made of these red urban areas, and then the more cream-coloured coloured classes of the agriculture, which is along the coastal plain. So that's really useful. We can now look at that burnt area in the context of the land covers around it and land uses around it, rather than just looking at the changes in vegetation index, for instance. But what would be even more useful would be if we could find out what had been, what was in this burnt area prior to the fire. Now, in order to do this, I'm taking the Careen 2018 data again, but I'm actually going to use oh, sorry, I've missed a part out here. Sorry. We have another section here where we're going to look at this this Careen data and the Sentinel-2 NDVI at the same time. So we're just going to crop them to a smaller area. We'll just look at a small section here of this data set. And so again, what we have is more of similar processing steps where we're cropping the various data sets, and then and then we're just going to display them as we did the value, the data sets higher up. And again, we have to process that legend again for Careen, just to make sure that we only display the classes that we are interested in that area. So what we can see here, this is a detailed Sentinel-2 image of the normalized difference vegetation index, and we can see the burnt area at the top here with the very low values of NDVI, and the unburnt areas below with higher values, and then that's duplicated in the Careen data. So we see the burnt area here, and then we have various classes of natural and semi-natural vegetation here that are remaining, that are unburnt. So as I was saying before, sorry, I got quite slightly ahead of myself. What would be really useful if we could take that Careen 2018 data and actually look at a more recent fire and say, okay, what has been burnt by that event? So here we have a fire from 2020. This is February 2020, and here is the Copernicus Emergency Management Service map there. So what we've done is taken this burnt area outline, which was provided by that service, and we've gone into that Careen 2018 data, so what it was prior to the burn, and then we've just done another crop here, and so we're just going to display that data again and again. We're messing around with the legends, but that's sort of a bit of code that can be copied and repeated. And so we can see here, this is that 2020 burn now, and how it appeared in the Careen 2018, and we can see that some of the areas were already burnt previously. So whether they're burnt back in 2017, so these have been burnt again, and then we can see the breakdown. We have some traditional woodland and scrub, which is a kind of low height forest. We have this sclerophyllous vegetation, which is a Mediterranean particular habitat type, and then we have some broadleaf forest, which was also burnt, but also some pastures. So the fire had spread out of the woodland and forest areas and down into the pastures as well. So we can see here that we've combined satellite imagery, we've combined outlines of fires, combined thematic maps, and generated a really rich set of information, which becomes part of an application and then a service that can then be delivered in the future. So I think I'll leave it there. I've probably just got up to my time, and then I'll hand back, and I guess we'll now have time for some questions. So thank you very much, everyone.
Thank you very much, Geoff, for the interesting demonstration. Indeed, we'll have some time for questions and answers, but before I start with that, I just wanted to quickly inform you about what's coming up next in our webinar program. So we have a series of 12 webinars on the WEkEO DIAS on different kinds of thematics, different applications. And at the moment, we're already in the 9th of our series, and we're doing at the moment thematic webinars for experts. So today was on land for experts, and what we have coming up is one on marine applications in July, one on climate applications in September, and then finally, if you're interested in developing something commercially, a commercial product, there will be a webinar on business applications towards the end of September this year. So if you're interested in participating in any of the other webinars, you will receive an automatic invitation after this event is over for the next one on marine applications in the WEkEO DS. So we hope to see you there. But don't go yet. Let's start with the Q&A session. So there have been some questions asked already. Perhaps one of the recurring questions is, will this event be recorded, or is a presentation available? So this event is being recorded. You will get an email with the link to the recording to the YouTube channel, so you will be able to rewatch this whole session. Next question. The next question is perhaps one for Geoff. After you get raw land cover data, is it vital that an image classification is done? And if that is done, do you use supervised or unsupervised classification? Perhaps a philosophical question.
Yeah. Well, yes and no. Or well, however it works for you, I guess. Yeah, I guess you mean once the raw imagery is available, then yes, we can convert that into a thematic classification. There are various methods. The Korean map is mainly done by visual interpretation, but some countries do use an automated classification, mostly of the supervised variety, where they take training data sets and then train the computer system then to identify different land cover types. So an unsupervised classification could be used, but then the results would then still have to be labeled to be given the correct nomenclature. So you end up with spectral classes, and then you have to identify what that spectral class represents in terms of the legend or nomenclature that you're using. I think that's probably about it for now.
Yeah, thank you. We also have a question on, can the data from the DIAS be used by third-party vendors?
Well,
Stefan?
yeah, I'll answer that question. Yeah, well, in fact, Copernicus data is made available by the European Union on a full, free, and open basis. What does that mean? That means that it can be used by anyone without any restriction other than having to mention that the data is from the European Union. And for Copernicus, there is on the website the text, but it's basically open data. So you can use it, you can add value to it, you can sell what you do with it without having to pay anything or without any restriction. It's basically, I remember that one of our colleagues once said, it's a bit like if the European Union supplied automotive manufacturers with free aluminum so that they would have the raw material for their products basically for free. So that's one of the very, very strong specificity of Copernicus in general, which is that you can use the data and do whatever with it, personal use or commercial use.
Thank you. At the moment, I don't see any further questions. But if after this session you're trying it out, oh, there is one more question. Yes. Is there any agricultural crop type product that has been done and is available for download by end users?
Shall I take this one?
Yes.
Okay, yeah, the Copernicus land monitoring service is in the process of producing a crop type product. I'm not sure if it's available yet. I haven't checked lately, but it's in the process. So if you continue to watch the Copernicus Land Monitoring Service website, then when it's available, it will be posted there.
I can complement that by saying there is indeed a product, but it's still in the production validation verification phase. It should be made available later this year. But there are a couple of commercial providers that use Sentinel data to produce detailed crop classification maps. I can think of at least one, just to show that that's a good example of the open data. They basically take Sentinel data, Sentinel-2. They also use radar, Sentinel-1, for cases to remove ambiguities, etc. One, I'll put their name in the chat. One is called One Soil. And in fact, it's interesting because it's not even a European startup. It's a startup from Belarus. So, yeah, but there will be an official quality certified and validated both through desk work and through field work. There will be an official European Commission product available later in 2021.
Just to add that I think the Copernicus one will just be for Europe, whereas I think One Soil also offers services globally.
Yeah, well, Europe, one thing we didn't say is when we say Europe for Copernicus Land Monitoring Service products, it means the 39 member states of the European Environment Agency. So it's not only the European Union, but it covers also Turkey, it covers also the Balkans, it covers also Norway, Switzerland, etc. And as far as One Soil is concerned, I think they cover part of South America. They cover Argentina in particular. They cover the US and I think Canada and maybe Australia, but not the entire world. But it's a rather impressive product just to show the power of this open data, because once we didn't know whether this was like, what was the quality of their artificial intelligence algorithms to determine the type of crops. And we sent a screenshot to a farmer that we happen to know in southwestern France, and he responded that the data was basically 98% accurate. So with Copernicus data and good artificial intelligence algorithms, you can really, really do some amazing extraction work.
Okay, thank you very much. In the meanwhile, there are no further questions that came in. Oh. One more. Are overseas territories covered by Copernicus products? For example, the French overseas territories or the Portuguese ones? Geoff,
I believe they are. I believe they are.
I think so. French, definitely.
Portuguese also. I remember seeing Azores, for example. I'm 100% sure that the CLMS products are available for Azores.
Yep.
Okay, great. Thank you. As you know, Google Earth Engine has Sentinel-2 data. Which are the advantages to use WEkEO as compared to Google Earth Engine?
Is Amin here?
Well, I would say the advantage of this, of using the WEkEO, is that you will have access to the original data sets because it's directly linked to really the original data portals for the different Sentinel data, but also it combines then with all of the Copernicus products from the services. And in addition, it's based in Europe and could be considered more stable than Google Earth Engine, whereby this is a service that Google is offering now. If Google doesn't see the value in it anymore, they might shut it down, and any of the work that you do on there is lost.
Yeah, typically the kind of processing that was demonstrated by Geoff, which combines data from several Sentinel satellites and data from a Copernicus service, that is typically not available on Google Earth, where you would only find the Sentinel, Sentinel-2 and Sentinel-1 data.
Okay. No, someone is typing. But if there are no further questions, I believe we're at the end of today's webinar. So I'd like to thank everyone very much. Thank you to the participants for this session, and thank you for the speakers, for the demonstrations, for the presentations. And we hope to see you again soon. Have a nice afternoon or evening or rest of the morning.
Bye.
Bye.
Bye.